sklearn, preprocessing, binarize. Description: binarize data set feature values to 0 or 1 according to a threshold. Inputs: X array like sparse matrix or pandas data frame. Data to binarize, where n samples is the number of samples and n features is the number of features. Threshold float. Default 0.0. Feature values below or equal to this threshold are replaced by 0. Above it by 1. Outputs: X binarized ND array or sparse matrix. Shape: n samples, n features. Binarized input data. Steps: iterate over each feature in the input data. Compare each feature value with the given threshold. Replace values below or equal to the threshold with 0 and values above it with 1. Metrics: accuracy. It measures the percentage of correctly classified instances, providing a general sense of model performance in terms of how well it predicts the target variable. Precision: it indicates the proportion of correctly predicted positive instances among all instances predicted as positive, highlighting the model's ability to avoid false positives. Recall: it measures the proportion of correctly predicted positive instances among all actual positive instances, reflecting the model's ability to capture all positive cases. Visualization plots. Feature distribution plot. This plot displays the distribution of values for each feature after binarization. It can help visualize the impact of binarization on the data. Confusion matrix. A confusion matrix visualizes the classification performance by showing the number of true positives, true negatives, false positives, and false negatives. Fine-tune parameters. Threshold. This parameter controls the cutoff point for binarizing the data. Adjusting this threshold can influence the outcome of the binarization process. Uncertainty methods. Confidence intervals. These intervals represent the range of values within which the true population parameter is likely to lie with a certain degree of confidence. Challenges and fixes. Challenge 1: choosing an optimal threshold for binarization. Sample use case that resulted in challenge 1 when data has a wide range of values. Selecting an appropriate threshold for binarization becomes crucial to ensure meaningful transformation. Fixes to challenge 1. Use domain knowledge to guide threshold selection. Experiment with different thresholds and evaluate model performance to determine the best value. Challenge 2: handling missing values. Sample use case that resulted in challenge 2 missing values can hinder binarization, as the algorithm needs to compare values against the threshold. Fixes to challenge 2. Impute missing values using appropriate techniques like mean, median, or mode imputation before applying binarization. Consider using specialized binarization methods that handle missing values directly.